Now we learn how to write the rate law with respect to the order of reaction. Okay, so we focus on rate law. Reaction equation is given. Okay, then let's look at the question. Okay, the reaction order. Okay, you see here the word already mentioned, the reaction order with respect to I negative iodide ion and S2O8 negative is 0 and 1. And then it says write the rate law for the above reaction. Okay, in this question, there are two things that you need to pay attention to. That is reaction order, okay, given or rate law only refer to reactants. Okay, we only write rate law only refer to reactants. Okay, another one is reaction order, we never refer to the coefficient or the factor of the reactant. Okay, but it is provided in the sentence respect to, okay, iodide ion 0, S2O8 is 1. Okay, so now let's write the rate law. Okay, rate law means you need to write rate equals to, must have K, rate constant, and then the concentration of your reactant, which we have 2. Okay, power, not power, actually it's the order, but here we write down like power. Okay, then we find out. Okay, so what we have here is, okay, let's move with number 1. Okay, we have order for iodide ion is 0. So when we know when it is power of 0, it is equals to 1. Okay, so remember when we have 0 order means we do not include in the rate law. Okay, now we move on to the next one, that is S2O8 negative ion. Okay, it is 1. Okay, if it's 1, okay, then we can write it down. But for rate law, we do not write the power of 1. Okay, not necessary. So remember to write the rate law, you must have the word rate, rate constant, and also the reactant concentration with the power or with actually referring to the order of the reactant. Okay, so it is 1, no need to write. Okay, another question. Determine the reaction order and the overall reaction order from the Rates law. Okay, this time the Rates law is given. Okay, same thing again. When we want to refer to the reaction order, do not refer to the coefficient given. Okay, so what is given here? Okay, we have 3 reactants, but here there's only 2 reactants. Okay, what does it mean? It means that one of the reactant is 0 order. Okay, so which one is not inside? Hydrogen ion. Okay, so hydrogen ion is 0 order. Okay, if you don't want to show it in your count, okay, but the question asks for determine the reaction order, right? Reaction order refers to each reactant. So we know that H plus, the order of reaction is 0. Okay, next we go back to one by one. Okay, let's go for BrO3 minus. Okay, BrO3 minus given power 2. If it's power 2, means that the order of reaction is 2. Okay, another one, we go to bromide ion. Okay, bromide ion, if you can see, I erase. Okay, if bromide ion, there is no power indicated here. Okay, it is empty, but however, it indicates that it is 1, not 0, it is 1. Okay, so the overall reaction order means that it is 2 plus 1 plus 0. Okay, or you can just write 2 plus 1. So total is 3. Okay, this one, the arrow is incorrect. The arrow is, for this one, not compulsory to show is in the calculation. Okay, now let's move on to next one. Okay, so points to remember. Coefficient are not the reaction order. If zero order, don't write in the Rates law. If first order, do not label power 1. Okay, now we go to another exercise. Okay, state the effect on the reaction rate. Okay, this time we focus on reaction rates, which we also use the Rates law. If the concentration of nitrogen monoxide is double, but the concentration of oxygen remain constant. Okay, they will give you the Rates law. Okay, so what happened when we change the concentration for the one of the reactant or two of both of the reactant? Okay, so given first says that nitrogen monoxide is double. Okay, when it's doubled means you have to add in 2 in the bracket. Okay, remain constant, you just put back the same. Okay, this one double, because double, so you have to put in 2. Okay, then this one is a new Rates law. That's why I put rate 1. Okay, so after that, we do mathematics and then we will get 4K and then the same rate law as the earlier one. Okay, so substitute 1 into 2, we will find that, okay, the new Rates law is 4 times of the initial Rates law. Okay, so how do we say the answer? We just say the reaction rate increase fourfold or increase by a factor of 4. Okay, now this kind of question is easy. Just what you do is write down the original Rates law and then the new Rates law you label R1 and then do mathematics in order that you can find out how many fold has increased, okay, or has decreased. Okay, now we move on to the next one. Okay, in order to increase the reaction rate, would you increase the concentration of H plus ion? Why? Okay, then here given the reaction order for each reactant, okay, it's given already 2, 1 and 0. Okay, so this time we have to write our rate law on our own. Okay, again, as I said, if it's 0, we do not have to include in the Rates law. And then if it's 1, we do not label 1. Okay. Okay, now let's look at this. If we have the Rates law, we only have H2O2 and I negative. H plus is not inside. Okay, when H plus is not included in the Rates law, means the changes of concentration has no effect on the reaction rate. So the answer is, you must answer no, because the even when the concentration is tripled, the reaction rate will remain the same. Okay, if let's say another question, if let's say I say if I negative increase, then surely reaction rate will increase. So that's all for this part.